In order to show that the binomial distribution boils down to Gaussian distribution in the continuous limit for large number of elements in the system, we need to discuss two mathematical notes here. The first one is the derivative of natural logarithm of n factorial for large values of n. So first of all, this n that we're considering in our discussion is a large integer. So let's have n be a large integer. So if I change the value of n by 1, so that I'm going to make an observation here. If n changes by 1, if I go from n to n plus 1, a natural logarithm of n factorial changes by how much? So I have to find natural logarithm of n plus 1 factorial minus natural logarithm of n factorial. So this would be equal to natural logarithm n plus 1 times n factorial divided by n factorial. So these would cancel. So it would change by natural logarithm of n plus 1. Now, the second observation I'm going to make is that the change in the value of natural logarithm of n factorial for n changing by 1 as n goes to n plus 1, which is given by natural logarithm of n plus 1, this number is always going to be much smaller than the value of n. Now let's demonstrate that. For example, let's have n is equal to 100,000, a large integer, 100,000. Then n plus 1 is equal to 100,001. Natural logarithm of n plus 1 is equal to natural logarithm of 100,001. That is 11.5. And as you can see, 11.5 is much less than 100,000. So this assumption or this observation that I'm making here is correct. Indeed, I have natural logarithm of n plus 1 is much less than n, for n being a large value. So this is always going to be true. Okay, so I have basically achieved here a change in the value of natural logarithm of n factorial by changing the value of n by 1. So what I want to get from here is use the definition of derivative in order to approximate the derivative of natural n factorial with respect to n for large values of n. So using the definition of derivative, what is the definition of derivative? df dx is the limit as delta x goes to 0, f of x plus delta x minus f of x divided by delta x. So here I'm applying this to the derivative of natural logarithm of n factorial with respect to n, and basically I'm going to approximate this by saying this is a natural logarithm of n plus 1 factorial minus natural logarithm of n factorial divided by 1. So my delta x here is 1, which is much smaller than the value of n. So indeed, instead of having delta x go to 0, having delta x becoming 1, it's sufficiently small for an approximate answer for this derivative. And the change in the value of the function f of x plus delta x minus f of x for delta x is equal to 1 is natural logarithm of n plus 1 factorial minus natural logarithm of n factorial. So this is going to be the ratio natural logarithm of n plus 1 factorial natural logarithm divided by n factorial. And this will be equal to natural logarithm n plus 1 times n factorial divided by n factorial. So the answer is natural logarithm of n plus 1. But since we have also n much greater than 1, it was a large integer value to start with, which is much greater than 1. N plus 1 is almost the same thing as n. Therefore, I have the following answer. For n being much greater than 1, the derivative of natural logarithm of n factorial with respect to n can be approximated to be natural logarithm of n. So that's the main conclusion for this discussion. I have found a quite good approximation for the derivative of natural logarithm of n factorial with respect to n for large values of n.